talking about adding and subtracting polynomials. This is going to be kind of a review. It goes with your 0A.09 homework. So if you have submitted that homework, I have graded, and if there was errors, I highlighted the terms that were incorrect. Based on the grading, it looked like most of you got adding polynomials pretty quickly, but we still need some work on subtracting. So we're going to spend most of today working on subtracting, but I'm going to do a short little lesson at the beginning, do an example on adding, and then we will go on to subtracting. No worries, Nola. Alrighty, so for today, some words, vocabulary that are going to be important to this lesson and in bigger this unit. We have constant, coefficient, variable, degree, distributive property, like terms, simplify, monomial, binomial, trinomial, and polynomial. So today we are going to start by identifying like terms so that we can add and subtract polynomials when written in standard form. And lastly, I'll know I've got it when I can correctly add and subtract polynomials with missing terms and not in standard form. So here's a little review of some terms. Actually, let's do this first. In the room chat, I want you to tell me what number is the constant, what number is the coefficient, and what number is the exponent. I'm going to give about a minute for you to type that out. Yes, 3, 2, and 2, but tell me constant is this, coefficient is this, exponent is this. Okay, so I'm going to give you about 1 minute. Good. Okay, good. So I'm seeing most of you are saying that the constant is 2. I see coefficient 2, exponent 2, constant 3. So let's go ahead and go over this. The coefficient is going to be, I'm going to type this out, this little definition here. Coefficient is going to be the number in front of the variable. So the coefficient in this example is going to be the number 3. We're going to talk later in our exponent rules about adding coefficients or adding exponents. So we need to make sure that we understand the parts of this expression. The exponent is going to be the little number that is above. Oops, it's not typing this out. Okay, let's do it like this. There we go. Number above the variable. Okay. It's going to be the little number. And then constant is going to be the number without a variable. Okay, so it's just a plain number. The constant in this expression would be 2. So the way that we would read this expression is 3x squared plus 2. Now, let's talk about polynomial definitions. So a polynomial is when you have 2 or more different terms being added or subtracted together. So as you can see, we have a term with a y, that's our variable. We have a constant, 2 terms or more, and they are being added together. So that's a polynomial. Polynomial is kind of like a very generic term. Okay, most things are polynomials. The only thing that's not a polynomial is a monomial. So mono means 1. So we're going to have 1 term. A binomial, just like a bicycle has 2 wheels, bi means 2. So a binomial has 2 terms. A trinomial, like a tricycle, triangle, that's going to be 3 terms. So polynomial can be 2 or more. So 2, 3, 4, 5, 6. It can go on and on. The next thing we need to talk about is degree. So the degree of a term is the value of the exponent. So for example, 4x squared has a degree of 2 because the exponent is 2. Okay, now this is one that trips people up. If I had 2x, the degree of this would be 1. Because there is an imaginary 1 on top of that exponent, because it is on top of that variable. The exponent would be 1. Some of you, and just people in general, get confused and they think that if you just have 2x, that the exponent is 0. However, if you raise anything, it can be x to the 0. It could be 1,000 to the 0. If you raise anything to an exponent of 0, the answer is 1. Okay, so if this variable is there, for instance, x is there, it's not gone, then we know that the exponent is 1. Okay, so just like each term can have a degree, the entire polynomial also has a degree. The degree of the polynomial is determined by the highest degree term. So you would look at the entire polynomial, like this one, 3x squared plus 2x plus 5. So the first term has a degree of 2. The second term has a degree of 1. The third term has a degree of 0. So to determine the degree of the entire polynomial, you look at the highest degree. So that would be 2. It's pretty rare that you'll be asked specifically for the degree, but it's important that you understand terms like 2 times x have a degree of 1. All right, the last vocab word that we're going to go over before we get started is called standard form. So standard form is when the polynomial is written in order of highest to lowest degree. These two polynomials, these are the exact same polynomial. One is written in standard form and one is not. The one on top is not in standard form. Okay? Standard form means I would find the highest degree, put it first, then the next highest, on and on. So, do I have anybody that would be willing to write out this degree, this polynomial in standard form? So, highest degree first. Okay, awesome. AJ, will you raise your hand so I can give you whiteboard tools? Everyone else, I want you to practice this on your own paper.
Okay. Do you want me to solve it? Oh, no, it's already solved. Sorry.
Yeah, no, there's no solving involved. You're just going to rewrite it in standard form. So, Raven, it's pretty rare that you would actually need to know the degree of a variable or a polynomial in real life. However, you're going to notice probably not in this specific unit, but when you talk about real world situations, such as like optimal business decisions. So if you want to say, okay, am I going to make more money to have 100 people working for 4 hours or 50 people working for 8 hours? And you try to like compare the productivity, all of that. Okay. That's going to always be in the form of a polynomial. And then when you reach the maximum or the minimum, whatever you're trying to find of that polynomial, that's where your optimal operating is going to be. So you're not going to use specifically the standard form of a polynomial in real life, but you will have to use the rules that we're learning to be able to use polynomials in real life. So You will need it. It's just you don't need this specific part like by itself, but you have to know this part to be able to use the part that you'll use in real life. Okay, perfect. Thank you, AJ. So AJ went ahead and hey guys, I'm really glad that you're paying attention to the room chat, but let's pay attention to the lesson. If I have to close the room chat, I will. Okay. All right. So the standard form, we want to find the highest term. So we're looking for the highest degree, which is 3x to the third plus 4x squared plus x minus 2. Great job, AJ. That was perfect. So now we're going to talk about adding and subtracting polynomials. Whoops. Alrighty, so there are 4 steps to, okay, so Jesse, we don't know what x is, so we can't for sure say that 2 would be more than x. Also, what we were doing in this one is writing the standard form. So we say that they're in terms of highest to lowest degree. The term 2 has a degree of 0. Okay, it would be like 2 times x to the 0, because x to the 0 is 1. So 2 times 1 is 2. This has a degree of 1. So 1 is bigger than 0, just in terms of degree. Good question. Okay, so there's 4 steps that you're going to follow when you're adding and subtracting polynomials. You won't always have to use all 4, but it's good for you to write these down or take a picture so that you can move through your checklist. The first thing you're going to do is check your polynomial. If it's not written in standard form, you're going to rewrite it. This is just an organization piece. You don't have to do this, but when people don't do this step is when they get a little bit confused or they start adding terms that are not alike. Then you're going to distribute to get rid of any parentheses. This is definitely important in subtraction. You're going to combine your like terms and simplify. So key piece here, remember that like terms means the variables and their exponents have to be exactly the same. Let's take a look at some, and I'm going to have you help me. We're going to do an example first, and then I'll have you help me decide if terms can be combined or not. All right, so we have 3x squared plus 4x squared. So first I'm going to check that they have the same variable, x and x. Great. Same exponent, squared, squared. Yes. So when I combine these, I'm using the sign in the middle. Okay. The sign is addition. So I'm going to add the coefficients. 3 plus 4 gives me 7. The base and the exponent stay the same. So when you're adding polynomials, you don't do anything with the base or the exponent. You're only adding the coefficients. Raven, we will add exponents, but that's actually a rule for multiplying polynomials. Okay, so you're going to learn about that in the course. I believe it's Friday. So we're going to talk about multiplying polynomials next week in class. Okay, but for right now, when you add polynomials, you add the coefficients, leave the base and the exponents alone. Okay, let's talk about 3x squared plus 2y squared. I'm going to give you a hint. These do not combine. Can you tell me in the room chat, why do these two terms not combine? What's not the same? Good, Jalen. There you go. Good, Kiara. The variables are different. Exactly. So the exponents are the same, but they're not the same variable. Very good. Okay. What about this one? 5x squared y plus 7xy. So they both have an x. They both have a y, but they don't combine. Why do they not combine? Good. Different exponents. Exactly. All right. Now, I'm going to let you do this one. 4x squared y minus 1x squared y. Tell me, we'll do a poll real quick. Green check if they do combine, red check if not, and then you're going to put in the chat what the answer would be, or they don't combine and why. So you're going to do the poll. Based on your answer in the poll, you're either going to tell me what the combined answer would be, or you're going to tell me why they can't be combined. Good. Very good. So these can be combined. I only have 18 of 42 people that have answered. Are y'all sleeping on me? What's going on? Can y'all please put your answer in the poll? So these can be combined because x squared and x squared, y and y, they have the same variables, and each of the variables has the same exponent. So I'm just going to use my sign in the middle, which is subtraction. So I'm going to subtract the coefficients. So 4 minus 1 would give me 3. So 3x squared y. All right, let's go ahead and practice an addition problem. I'm going to move sort of quickly through this because I think most of you have got this down, and I want to get to subtraction. So the first thing on my checklist says to rewrite in standard form. So I'm going to check each of my terms in the parentheses and make sure they're in standard form. So we've got x squared, x, and then no variable. Perfect. Same with the second set of parentheses. Okay, so far so good. Then I'm going to distribute. So I don't have to distribute anything. Okay, this is a positive 1. So I'm just going to leave that alone. What I personally like to do, and what I saw a lot of you utilizing in Class Kick, which was really awesome, is we're going to use colors, or you can do shapes if you like to do shapes. Okay, so I'm going to, hey Raven, if you will just stop typing in the room chat for a second, I'm going to explain how to do this. Okay, so just ignore the room chat. I'm going to tell you how we get this. Okay. All right, so I'm going to let green be x squared. So terms with an x squared. So I have a term right here and a term right here. Then I've got blue, which is just going to be anything that's just an x. So there we go. And then finally, red will be my constants. Okay, guys, I'm going to take the chat away because it does not seem that we are able to handle it. Okay, so I'm going to take it away for now. You'll just have to do your work on your own. We're not going to submit our answers right now until we can be mature enough to handle the chat. All right, so I'm going to combine the like terms. Combine means I'm going to use the sign that's in between the parentheses. So I'm going to add the like terms. So in my green, I've got 6x squared plus 2x squared. Those are my like terms. Blue, you don't have to do this step. This is a rewriting step for people who maybe are not going to use colors and they just want to rewrite all of the terms together. That's totally fine. Or if you want to do this extra step just to help you stay organized, that's totally fine. If this step is kind of redundant for you and you don't feel like you need it, you do not have to do this step. All right, so now 6x squared plus 2x squared. I add the coefficients. 6 plus 2 is 8. The base is going to stay the same. 4x plus 3x is going to be 7x. 5 plus 1 is 6. So I wrote it out kind of long ways here so that you could see exactly what I'm combining. And then when I combine them, the term that I got. Okay, before I move on, does anyone have any questions about any of these terms, how I got these terms, or the steps I used? Alrighty, let's go ahead and take a look at some subtraction. So I'm actually going to do this first one with you, and then we have two more. So if you would like to volunteer to work those, that would be great. Let's go through our steps. It says to rewrite in standard form. Both of these parentheses are already in standard form, so that step is done. Now, the second step says to distribute, which means get rid of any parentheses. So we have an imaginary 1 on the outside here, okay? This is saying all of this, 6x squared plus 4x plus 5, we're going to subtract everything in here, not just subtract 2x squared. Okay, we have to subtract 2x squared, we have to subtract 3x, and subtract 1. So there's two ways you can do this. Some people, I personally, like to actually distribute this out. So I'm going to draw a little arrow, and then I'm going to rewrite that second set. Okay, so I'm going to rewrite my problem. I would have 6x squared plus 4x plus 5. And then negative 1 times 2x squared would be negative 2x squared. Negative 1 times 3x would be negative 3x. And negative 1 times positive 1 is negative 1. The other option that some people like to do is from the start of your equation, and again, you can absolutely do this. Yes, distribute means to multiply. Good question. Some of you will prefer to say, okay, I'm just going to make this middle, the subtraction, I'm going to make it a plus sign and add a negative to all of my terms. Or do the opposite. So if you had a negative number starting in parentheses, you would make it a positive. You can do it either way. For some people, the top way is faster and they can understand, oh, 6 plus negative 2. Great. Some people need less writing, okay, so they don't want to have a plus sign and a bunch of negatives added in. And you can just use the multiplication, distributing that negative 1. What I'm going to do now is go back through and highlight my like terms in the same colors. So 6x squared and negative 2x squared. Don't forget to include the sign in front of your number. Okay, now 4x and minus 3x, 5 and minus 1. I'm going to rewrite this with all my like terms together, just in case anybody needs it that way. If you don't, you can just ignore this step. Alrighty, so we would have 6x squared minus 2x squared plus 4x minus 3x plus 5 minus 1. So 6 minus 2 gives me 4x squared. 4x minus 3x gives me 1x, or just x. You can put plus 1x if you want. I'm just going to put plus x because that's the answer choice you'll see if you have multiple choice or on the STAR test. And then 5 minus 1 is 4. Okay, I'm going to pause here for just a second. Does anyone have questions about any of the steps, how I got any of the terms, or any other questions in general? If you do, send me a question.
Why aren't one of them, why are only one of them subtraction and not both of them?
So this negative 1 on the outside here it only gets distributed to this second set of parentheses. Okay, we don't have a -1 on the outside of this parentheses. So we don't multiply the first set by -1 because we don't have any indication that we need to. The only reason we technically multiply the second set is because sometimes with this minus sign, people will do 6x squared minus 2x, but then they forget that they're still subtracting. So they just look at 4x plus 3x, but it's 4x minus the positive 3x. So by using this distributive property, we just are able to rewrite it so that we don't forget that we're subtracting every term.
Oh, okay.
Good question, Raven. Okay, I'm going to go ahead and put this one up. If you would like to work this one on the board, would you raise your hand? Would love to have a volunteer. The rest of you, if you're not volunteering, thanks, Amari. Let's go ahead and you're going to work this one on your own. I'm going to open up the room chat, but I'd only like to see the answer posted in there. You can also, if you post the answer and you see one of your classmates post their answer and something's different, you can start that conversation and say, hey, I think you have this term incorrect. Okay, but I want to keep the chat to things about math. Okay, we don't want to be distracting anyone else. Good, Amari. That's a good start. So she just distributed the -1. Perfect. And actually, you can take those parentheses away. So the distributing gets rid of those parentheses. So now we're able to combine. So be careful here. The second set of parentheses is not in standard form. So if you get in the habit of just adding or subtracting the first two terms of each parentheses, be very careful on this one, okay? You do not have to write the 0, Jesse. Good question. And Jalissa, yes. Well, the -1 and +1, it's not negative and +1 because remember we're distributing. So -1 times +1 becomes -1. Yeah, so it's actually going to be -1 minus 1. But there is something else. Yes, Maya, that's right. There is something else that cancels. Okay, so Amari, before you get going too far, remember this is 5 minus 6, right? 5 minus 6. So what is 5 minus 6? Raven, the -2 is from -1 minus 1. Good, Amari. There you go. So 5 minus 6 is -1. So we get -1 x squared. So then, Amari, what you have for the next one is positive 2x minus 2x. So what's 2 minus 2? 2 minus 2 is just 0. So we don't include that. Those end up canceling each other out. This is why subtraction can be kind of tricky. So these cancel. So we actually lose one of our terms here. You can write plus 0, but you do not have to. We just, those cancel out, and then we are left with this negative 1 minus 1. So you can go ahead and write that number in there. Good, perfect, Amari, good job. So we get negative x squared minus 2. Good job. So you can see that subtraction can kind of be tricky. Okay, we got to make sure that when we distribute, we go to every single term and then follow the sign that's in front. All right, I have one more problem that I would like for us to work on the board. Do I have anybody else that would like to volunteer? Perfect, Amari. So Gilbert, okay, Maya, I'm going to give you whiteboard tools, okay, because you haven't gone yet today. Go ahead, Maya. You can start working this one. Gilbert, good question. If there's a variable outside both parentheses, then you'll have to do the distributive property to both sets of parentheses. Good question. I know, AJ already went though, Raven, and we're not really worried about things that aren't math, okay? Nobody's picking on AJ. She already volunteered today, and she did a great job. Gilbert, are you looking at a certain problem, or are you just like thinking of problems? I can help you if I know if you show me like how it's written out. Okay, which one, Gilbert, and what homework? I can help you with it at the end of class if you want. Alrighty, so let's take a look at what Maya's got here. So first she distributed the negative, so we get negative 3x squared minus 2. That's perfect. Then we've got 2x squared and negative 3x squared. We have x, and that's actually the only one. And then we've got 1 minus 2. So 2 minus 3 gives the negative 1x squared. X does not have anything to combine with. That doesn't mean it goes away. We just bring it down as it is. So plus x, and then 1 minus 2 is negative 1. Perfect. Good job, Maya. You did awesome. Okay, Gilbert, what question and on what slide? All right, so here's what I want to do. I am going to put up a poll. This is your question for our exit ticket. So before I put this up, I'm going to explain a few things. When you're going to work this problem out, once you have voted, you are going to go to a breakout room. There's one breakout room where I have this worked out on the slide for you. So you're going to check your answer. Once you check your answer, if you got it correct, you are going to go to 0A.09 homework. If you did not get a 100% on it, I want you to make those corrections and then raise your hand again. Okay, if you did get a 100% on it, then you can go to today's lesson in the course. Okay, so I'm going to put the code or put the poll up. You're going to vote. You're going to work this problem. Then you're going to vote. If you get it correct by checking the breakout room, you are free to go work in class kick. If you did not get it correct, you're going to come back to the main room, and I'm going to work this problem out all together at 10:42. So in 4 minutes. Okay. Okay, Gilbert, I'm going to pull up. Are you in the class cake assignment right now, Gilbert? Okay, I'm going to meet you on your page, okay? Okay, so this is not outside. It has to be in front. So the first thing that you're going to do is just circle your like terms. So this 2x that's at the end, it's just another like term. Okay, so you can just circle, continue with your colors, your like terms. These first 3 look awesome. You're doing great. All right, I've got 19 out of 39 people that have answered. So I need 20 more of you. I need y'all to answer, okay? All right, let's see. Emily, do you have your answer yet? Maurice, Ketsia, Riley, Sophia, Wasma, Ty, Micah, Jesse, Jasmine, you're good. Nate, Allie. Are y'all following along with me? Riley, are you there? Okay, I still need you to do the poll, please. Riley, are you there? All right, Riley, I'm gonna call you and your LC after class to make sure that we can get you pulled in the right direction here, okay? I don't know if maybe we need to check your internet or what. All right, so I'm going to go ahead and end this poll. The correct answer is H or C. Let's see. I'm going to bring everyone back. All right, guys. So if you are just coming back in or you didn't get to this question, I'm going to color or highlight, use colors to highlight the like terms here. I'm going to move pretty quickly since we're almost out of time. 7r and 5r, and then negative r squared and negative 6r squared. So, yeah, go ahead, Nola. 8.11 isn't on Class Kick. Sorry, Maya. 8.11 is a quiz. So if you want to go work on your quiz, that would be great. 8.12 is in Class Kick for tomorrow. All right, so I'm going to start with my highest degree first. So -1 plus -6 would be -7r squared. 7r plus 5r is 12r. And then 10 minus 18 is -8. Okay? All right.